Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Zener diode and voltage regulation. Let's begin. Zener diode is a special type of PN junction diode which is properly doped. Zener diode is a properly doped semiconductor diode which has a sharp breakdown voltage, and it was first of all invented by the scientist C. Zener. As a result, the name like Zener diode. Its symbol is just like ordinary diode with the bar turned into Z shaped. Ordinary diode, this is the arrowhead, this is the bar. Zener diode, that bar changed to Z shaped. That is the symbol of Zener diode, and that Zener diode is always in reversed biased. Let me explain it. General PN junction diode this is the P type semiconductor, N type semiconductor. The majority charge carriers are holes. Here the majority charge carriers are the free electrons. But in case of Zener diode, means that one is heavily doped. Heavily doped in the sense the doping concentration is too high as comparison to that of normal doping in case of diodes. Here the majority charge carrier concentration is too high as comparison to that of previous one. Similarly, free electrons, doping concentration is high as comparison to that of normal PN junction diode. What exactly happened here? If we connect that PN junction diode in reversed biased, so P type is connected to negative terminal, N type is connected to positive terminal. So negative, positive. Similarly, here P type is connected to negative terminal, N type is connected to positive terminal. At that of situation, here the free electrons are filled at the top holes, and we obtain the depletion region. A potential barrier developed, negative potential, positive potential, that is the barrier potential. Similarly, here also that electrons again fulfilled by that of holes, potential barrier developed negative potential, positive potential. In that of normal PN junction diode, that depletion region is too high as comparison to that of Zener diode, because in Zener diode these are heavily doped, but in normal situation that one is less doped, or the doping concentration is low as comparison to that of Zener diode. Therefore, the depletion region is too high as comparison to that of Zener diode. As the doping concentration is high, so here the electric field generation from positive to negative electric field will be high as comparison to that of Zener diode. As we know, E is equal to dV by dx, negative potential gradient. As a result, a huge number of electrons are flowed and a reverse current is suddenly high at a certain range of voltage, and heat is generated, heat produced, and finally due to a large amount of heat is generated, as a result that PN junction is destroyed. But in case of Zener diode, that heat produced is in very small amount, and therefore it is restrict, and we obtain a safe instrument, a situation we obtain this is the voltage and current, the forward voltage, forward current, reverse voltage, the reverse current. In the reverse voltage, at a certain potential, suddenly the flow of current increases, and that potential is known as the breakdown potential, that is known as the breakdown voltage. Breakdown voltage. Similarly, in case of reverse situation, in forward situation, at a certain voltage the flow of current increases, and that point is known as, that voltage is known as the knee voltage. But in reverse biased, here in normal PN junction diode, heavily heat is produced and the instrument is destroyed, but in case of Zener diode, it acts on that particular reverse biasing situation. It is safely active in reversed biased this is the PN junction diode, PN diode, that one is Zener diode. This is the normal junction diode, that one is Zener diode. As we say, Zener diode is always reversed bias situation. Again, due to that property of Zener diode, we use Zener diode as a voltage regulator. How? We explain it. How Zener diode as a voltage regulator. We use Zener diode in a special type of arrangement in order to achieve its function as a voltage regulator. The arrangement is just looking like this. This is the resistor which is connected to series with the Zener diode. That Zener diode is reversed bias, that end is connected to positive, that end is connected to negative. A load resistor, we know that when the AC input voltage of a rectifier fluctuates, its rectified output also fluctuates, means we get a pulsated DC. To get a constant DC voltage from the AC unregulated output of a rectifier, we use Zener diode. Here the unregulated voltage, that is the unregulated DC voltage, unregulated voltage from the output of a rectifier, unregulated voltage is the combination of AC as well as DC components. A small amount of AC components will be there. That voltage is connected to that Zener diode through a series resistance Rs. Such that Zener diode is reversed biased, that end is connected to positive, that end is connected to negative. So, it has two situations. One is either the input voltage increases or that input voltage decreases. Then we show how that Zener diode act as a voltage regulator. which is the load resistance RL. At the output we obtain regulated voltage V of Z. Now current, load current. Two situations we obtain. First one, if the input voltage increases, then what happened? The current through Rs at the series resistance and Zener diode also increases. This increases the voltage drop across Rs. This increases the voltage drop across Rs without any change in the voltage. Across the Zener diode. Okay. Now, due to increase of that voltage, now regulated. So, how it is regulated? Because this is because in the breakdown region, Zener voltage remains constant. Even though current through the Zener diode, changes. As it is shown from that of graph. So, that is the cause. This is because in the breakdown region, Zener voltage remains constant even though current through that of Zener diode always changes. That is why as we input that of unregulated voltage, then it is also regulated by using that Zener diode. Next situation, if the input voltage decreases, similarly if the input voltage decreases, then how it is controlled? The current through Rs R of S and Zener diode also decreases. Also decreases. The voltage drop across RS decreases without any change in the voltage across the Zener diode. Any change in the voltage across the Zener diode. Now, if that input voltage decreases, then the current through RS and Zener diode also decreases, and the voltage drop across RS decreases without any change in the voltage across that of Zener diode. In this way, either increase or decrease in that of unregulated voltage, but finally we obtain that regulated voltage. So, finally, thus any increase or decrease in the input voltage results in increase or decrease results in increase or decrease of the voltage drop across RS without any change in voltage, without any change in voltage across that of Zener diode. Thus, the Zener diode acts as a voltage regulator. Now, the Zener diode it acts as a voltage regulator, and we can easily select the Zener diode according to our required output voltage and accordingly the series resistance RS. So, here with the help of this video lecture we understand what is Zener diode and how that Zener diode we can use as a voltage regulator. And the circuit arrangement, if the voltage is increases, then how it is regulated. Next, if the input voltage decreases, then how it is regulated by that of Zener diode, and finally we can say the Zener diode acts as a voltage regulator. So, with this useful and informative notes, let me wind up this session. Thank you.